welcome to Chemistry Simplified. Today's topic is the mole. There are three reasons why the mole can be confusing for people. The first reason is they're thinking of this: the cute little fuzzy mole that your daddy wants to kill because it's tearing up the lawn. If you're thinking of this mole, you probably belong in a biology course. The mole that we're talking about in chemistry is a number. The two main reasons why people misunderstand this number is because they have a poorly written textbook that overcomplicates the subject, or a teacher who overcomplicates the subject. Basically, a mole is a unit. The definition of mole is 1 mole of any element is the amount whose mass in grams, or molar mass, is numerically equal to its atomic mass. But let's start at the beginning. Everyone knows that a pair equals 2, right? A dozen equals 12. A baker's dozen equals 13. A score is 20. And so on and so forth. However, people are lazy, especially chemists. We don't want to say we have 20 eggs. We want to say we have a score of eggs. We don't want to say we have 144 potatoes. We want to say we have a gross of potatoes. We don't want to say we have a pair of shoes, or we don't want to say we have 2 shoes. We say we have a pair of shoes. Chemists are the same way with the mole. To start off, let's define the mole as a number. 1 mole equals 6.02 times 10 to the 23rd. Now, a mole has much more on after the decimal point, but for simplicity's sake, we're just going to say 0.02. Some teachers prefer 6.022. Some people prefer more decimal points. Some teachers are nice and they just say put 6 times 10 to the 23rd. But for our purposes, we'll just use 6.02. This number is called Avogadro's number. If I misspelled that, don't be mad. It's probably in your textbook. You can look up the correct spelling there. Avogadro's number is this little beauty. It basically defines the number of atoms in 1 mole. We know that there are 12 eggs in 1 dozen because we can count them. We cannot count atoms, and we cannot count electrons. We cannot do that. It's way too complicated. So our little shortcut is mass. If we wanted to ask how many moles are in a substance, rather than getting a super huge microscope that probably doesn't even exist because it would have to be so powerful and you wouldn't have access to it even if it does exist, we weigh it. You get a little scale and you weigh out how much carbon you have, how much sodium you have. You put it on a scale and you get its mass. Mass is always given in grams or kilograms, but we prefer grams. The problem with this, however, if you look at the periodic table, you may not have covered this. If you haven't, go back to your textbook, look it over. My guess is that you have covered it if you're looking at this. The problem is that not all atoms are the same. as you can see from my little subscript, the radius changes. And when the radius changes, the size of the atom changes. And when the size of the atom changes, the weight of the atom, the mass of the atom changes. If you have one atom that's about the size of a ping pong ball, it's going to weigh a lot less than the atom that's the size of a bowling ball. It's just how stuff works.